Hello, I'm Jaime Corsetti and I'm going to present you Open Vocabulary Object 60 Pose Estimation, which is our latest work in unseen object pose estimation. In this task, we wish to estimate the 60 pose of an object which has not been used at training time. Current models for tackling this task can be classified in two families. The first are model-based methods that require the 3D model of the unseen object, and the second is model-free methods that instead require a set of reference views. Usually those are extracted from a video sequence of the unseen object. In this work we wish to relax the assumption on the references, and in order to do so we introduce a new open vocabulary object pose estimation formulation. Along with this we introduce Orion, which is a novel method for tackling this task, which is based on a textual prompt inputted by the user. This prompt describes the object of interest in the query image, and we additionally use a single RGBD reference view of the novel object that can be of a different scene of the query image. In this way, we do not need any 3D model or video sequence of the unseen object. Our method is based on CLIP, which is a vision language model, and this is used to extract vision and textual features from the input data. Additionally, we adopt a guidance backbone to extract high-resolution features from the images, and a fusion modules based on cost aggregation to fuse the image and textual feature in a single multimodal representation. This representation, however, is low resolution, and we upsample it by using a decoder. This outputs a high-resolution feature map along with the segmentation mask that localize the object of interest in the two scenes. Our optimization objective is dual, as we first optimize the mask by using dice loss, while the features are optimized for image matching. This is done by adopting an hardest contrastive loss, which uses ground truth matches as supervision. This loss has two terms, which are the positive feature loss and the hardest negative loss. At inference time, we first compute the feature map and the segmentation mask, and the latter are then used to filter the features in order to retain only the one on the object of interest. The resulting features are used to compute 2D matches by nearest neighbor, which are then lifted to 3D by using the depth information and the intrinsic camera parameters. The resulting 3D matches are registered by using PointDSC, which is a point cloud registration algorithm that can output the final pose between the anchor and query image. We evaluate our method against a pipelines built by image matching method paired with Open Vocabulary Segmenter, as we are the first method to tackle Open Vocabulary pose estimation. We evaluate Orion on a benchmark built from REAL and Toyota-Light dataset, which comprises 4,000 pair image and object instances which are manually annotated with descriptive prompts. As training data, we rely on synthetic images from ShapeNet 6D, while we obtain the textual prompt from the metadata of ShapeNet. In this table you can observe our results, and we can see that we outperform both baselines, both when using our predicted mask, and also when using the mask from OVSEG, while on the right you can observe that the qualitative results that show that the poses predicted by Orion are visually accurate. We also carry out an ablation on the prompt at test time in order to check how important the composition of the prompt is. We can observe that when we drop the description from the prompt, or we instead use a description which is misleading, the performances drop both in MIOU, which measures the mask quality, and also in AR, which measures the pose quality. Instead, when we completely remove the name of the object and have a prompt, for example, a brown open object so that the object name is removed, both segmentation and pose estimation fail completely. In conclusion, we have introduced a novel model and a novel formulation for the Open Vocabulary pose estimation task along with a new benchmark. Our method has a few limitations. For example, it requires depth information that could not be available in all cases, and also the textual prompt could be difficult to express for some objects like industrial components. Moreover, the variety of the prompt is limited by the type of training data we adopt. For our method, the code and data is free and available on our website. And if you are attending CVPR this year, we can meet for a chat on June the 20th in the late afternoon at Poster Session 4 at the exhibit hall. Thank you for your attention.